Assalamualaikum warahmatullahi wabarakatuh and good day again. So this is part 2 of the soil classification in soil mechanics. So in previous video, we already discussed how to identify the soil if we go to the field. So we can do visual examination, feel the soil, measure their compactness, and check for their cohesion, plasticity, and also consistency. And by looking to their colors also, we can define and get some more ideas on the type of the soil. Okay, in addition, you can also carry out the plasticity test, which we can see also this video attached here to looking more how they do the differentiation test between the soil. So usually we try to mold the soil into a ball in our fingers, in our hand, and we try to make the soil like a ribbon or snake for a long of 1 to 8 inch wide. So if it is okay, it holds together, so the soil is considered to be cohesive. So if not, so the soil might fall in the sand or mixture of sand or sand or clay or silt. But usually to do this test, some of experience need to be built first, so you can differentiate between the types of the soil. In addition, you can also do dry strand of test, very simple test that just need to take the soil at its natural moisture content, moisture condition. So try to crush the soil. So if it's crumble on its own, so it is a granular. But if the soil stick together in the smaller stiff clump, so it much more like a clay. And if the dry soil breaks into the clump, so we can see also either it has a fissurous or unfissured soil. Means it is organic or not organic soil. Okay, so that's all about the soil identification system that we want to do in the field. Okay, so next is the soil classification system, and which associate letter with the laboratory testing. So we have basically two major systems worldwide. We have US system. So usually we have USCS and also H2O. And similar to USCS, actually we have a British standard soil classification system. And we also have an Australian standard soil, but usually in our place we usually refer either to US or BS. And for the soil, so what the clear difference between them is how they draw a borderline between the coarser and also the finer grain size of soil. So for USCS, they opt 0.075 to become their border. So if anything lesser than 0.0075 in sizes, so it is considered as a finer grain soil. If bigger than 0.075 is considered as a coarser grain soil. So in the coarser grain soil, it can have sand, gravel, cobble, and boulders. But for British standard, the borderline is at 0.0063. The borderline is at 0.0063. So lesser than this is considered as finer, bigger than this is considered as a coarser grain. And if I could highlight also, anything that's bigger than 4.75 is considered as gravel. So passing uh, any particle that smaller than 4.75 is sand. But compared to BS, when in BS, anything that bigger than 2 millimeter is already considered as a gravel. So sand is much more smaller than that. Okay. So if you could see also just now, for the coarser fine material, usually sand, coarser grain material, usually sand, we usually do sieve analysis tests in laboratory. Whereas for the clay and silt, we usually do sedimentation analysis, and another one is also ultimate limit to test their cohesion or plasticity state. Okay, and both of the testing is in our laboratory courses is based on BS 52 1990 for dry sieve and also for the ultimate limit. Okay, so this is sedimentation. So usually we have a sample of soil. Just put the soil in the jar that filled with the distilled water. So we want to see either the soil particle is easily to settle from a suspension. So we need also have some experience handling the test. By the end of the day, we can have a value of the sedimentation. Okay, next, the dry sieve analysis is a test that usually we have a multiple stack of sieve, and the sieve size is differ compared to other. So we can have a smaller sizes at the bottom and bigger size of sieve at the top. And usually in one test, we limit the number of sieve up to 8, and the various of sizes can follow the BS standard or US standard. So this one is on BS standard. And if I could show you again, the sieve is done by shaking the soil sample through a set of sieve uh, which has a progressively smaller opening. And the results from the sieve can be plotted as a particle size distribution curve, and later we can see this curve. And finally, at the end of the test, we can characterize the soil. Either it is a poorly graded soil or well graded soil. So let's see the video. So as we see just now in the video, so we do the test by using the shaker. And bear in mind, for the fine grain soil, you have to use the brush to help you to collect all the soil, to weight the soil. And please do not use any pencil or sharp tools to remove the grain, because it might jeopardize the grain size, the sieve size that has been designed for the sieve. Okay. So just now, if you could note that every sieve has their own numbers, and for designated numbers usually is designed for a specific opening, such as for sand, to define any sand. So we usually ask for the passing size number 4. So for US, the passing size number 4, the sieve size opening is 4.75 millimeter. For BS, could be 2 millimeter. So usually the popular sieve number is 4, 10, 20, 40, 60, 100, and also 200. So number 4 and number 200 is the barrier between the sand, and also this one is for the final material, the clay. So we usually want to check these two two sieve size passing percentage. Okay, so this is shaker, the soil sample, weighing the pan and also the sieve with the soil, and stack them, the bigger size at the top, smaller at the bottom, and for the soil, and do the weighing, and and collect the data. So let's say this is another example of the data. So note that every time to do the test, we need to know the initial mass. We need to know the initial mass first. We need to careful with the sieve number and also sieve size. And what is the total mass after the test? Total mass after the test. So note that here they have a slight missing 2 grams. Missing a 2 gram. So if you could see here, we need to redo the do some correction, as long as the percentage that missing is less than 2%, so the test is accepted. So we just need to define the percent of mass retained, or straightly calculate for the percent of mass passing also can. But in this table, they do like this. So we got all the percent fine, and later we need to plot the graph. So I think that's all for this video. See you later.